Okay, so this is my thesis project. It is an OptoSensor specifically designed for multi-touch and multimodal input to be used behind LCD monitors to replace existing computer vision techniques essentially. A little bit about the hardware. The hardware in its essence essentially is each sensor is connected using a simple voltage divider circuit, which is then hooked up to a 12-bit ADC, which then connects to a microprocessor. One thing to note is that the microprocessor has, well, this is an Mega 1280 Arduino board, but Arduino Mega, but it has a custom bootloader flashed onto it, which was essentially designed so we could handle the fast frame rates this hardware is capable of delivering. This hardware can achieve a frame rate of up to 2,500 frames per second, but my computer just isn't fast enough, and I'm sad to say that my computering side, my programming on my computer level side isn't that great that I can design an application that can utilize those frame rates efficiently. But at the moment the hardware is running at 800 frames per second. I've written a simple processing application which just has a visual output. Key thing to note here is that one of the ADCs is not functioning properly. I think ADC 9, which needs to be replaced. Because of this, you may see a few glitches here and there on the sensor side, but it's a small problem that can be fixed pretty quickly. On the software side, we need to note that the software is running at 1,000 frames per second. To simulate touches, I'm using a simple IR pen, my traditional one, if you've seen any of my videos before, but here we go. So as you can see, I've got I'm around 1.5 to 2 inches away, and we can get a nice input going. Since it's a 12-bit number that we're sending out from 0 to 4095 unsigned, essentially that data gets sent across via serial to the computer, and here we have a small printout of how each of the frame is looking like in its raw form. Ideally, when you want to be manipulating data such as this, you don't want to be applying computer vision techniques to a non-optical based system when you have access to the raw data such as this. Okay, here I've got some simulating an input touch. As you can see, I'm simulating it pretty far away. This is to ensure that if I have my LCD panel and my acrylic and everything on top, that I can still register inputs. And you can see that the inputs are very easily registered. There is no delay as such. Yeah, that's pretty much about it. Key thing to note is this is a prototype hardware. In the final revision, the microprocessor will be embedded into the secondary board here with the ADCs. Another thing to note also is the fact that this will be a cascading system, so there will be multiple modules such as this connected together, controlled by a master microcontroller that will gather all the data and pass a raw frame down to the computer to handle and process the information. Ideally, you'd want something like your own DSP board, which gathers that data, processes it, and sends it across. That way, utilizing less CPU cycles and whatnot, because essentially what you're doing is signal processing here, and a computer CPU really isn't designed for specific tasks such as that. Alright.